Okay, practical voltage source, practical current source. Load characteristics, okay, when the load is connected to a practical voltage source. Similarly, when it is connected to the practical current source. Similarly, we also discuss that the voltage source must not be shorted and the current source must not be open. Okay, so many things. I mean, we have really discussed a lot of things over there. So very important for the exam point of view as well as entry point of view. Now the second classification is left over here, that is independent and dependent sources. Okay, so please take down here the classification of the energy sources. Second type of classification is that independent source and dependent source. What is an independent source basically? Okay, it is a source whose value does not depend on either current or voltage anywhere in the circuit. You change current, you change voltage at any part of the circuit, but this particular source value remains same. Let us say if it is a voltage source, 10 volts means 10 volts forever. It does not depend upon the variations that they happen elsewhere in the network. Okay. Similarly, current source 10 amperes means 10 amperes. That's it. So independent source means, okay, its value, okay, its value does not, please take down, does not depend on either current or V voltage elsewhere in the network. Okay, elsewhere in the network. Now let me take let me take an independent voltage source here. Let me take independent voltage source here. Suppose, for example, is a 10 volt source. Okay. Look at this. 10 volts means 10 volts. That's it. Okay. It supplies the power. We can define more elaborately the independent voltage source. Okay. It's something like this. See, its value does not depend on either current or voltage elsewhere in the network is a standard statement for what is an independent source. Okay. So its value does not depend on. Now 10 volts means 10 volts. You make any changes in the network, this particular 10 volts remains 10 volts. That's it. Okay. But what happens to the current I? The current delivered by the source, okay, it may change with respect to the load or with respect to, any changes that may occur in the network. Then what will happen? The current may change here, right? Yes or no? So in general, we write something like this. If somebody is asking you to define the independent source or independent voltage source, you can define like this. It supplies, okay, it supplies power at a constant voltage, It supplies power at a constant voltage. 10 volts means 10 volts, but current I may change with respect to load. Not only with respect to load, but with respect to any changes that may occur in the network. So I am just writing in general with respect to load, but not only with respect to load. Any changes that may occur in the load, what will happen? That directly reflects on what? The current delivered by the voltage source. Okay. Now, hope you can understand. Now you can easily write the current source similarly. 10 amperes means 10 amperes. But the voltage V, it may again change, okay, with respect to load or with respect to any changes that may occur in the network. That is why, what is the independent current source? Exactly, it supplies power at a constant current, but voltage V may change with respect to load. This is the way you define the independent voltage source and independent current source. So please make a note of it, and you should also remember and fix in your mind that in case of voltage source, we know the voltage most of the times. We need to find current. In case of current source, we know the current. We need to find voltage. In case of voltage source, we know the voltage. We need to find current. How do you find the current? Either by using Ohm's law or by using KCL. We know the current here. In the case of current source, we need to find the voltage. How do you find the voltage? We can find the voltage using either Ohm's law or KVL. Simple that you are dealing with either with the current or with the voltage. In our entire network analysis journey, what is your objective is just to find the current or voltage. You can find the current either using Ohm's law or KCL. You can find the voltage either by using Ohm's law or KVL. That's it. Yes or no, all of you? Okay. So please note down. Note down. Then we'll switch over to dependent source concept. Now coming to the dependent source, what is a dependent source? People call it even controlled source. Controlled source. Controlled source. Okay, dependent source or controlled source. Now tell me, if you go to an electric shop and ask him, I want a dependent source, what could be his response? Do you think that you're going to get a response from him? No. Because this element does not exist in reality. It is not a practical element. It is an imaginary element, a fictitious element, which does not exist in reality. Then you can ask, sir, why then we are really using this particular source which does not exist in reality? In the analysis of networks, maybe using electronic components or some other, okay, sometimes we need to create mathematical models. Okay, see, the mathematical models are created and using which we construct the equivalent circuits for certain elements like transistor, operational amplifier, okay, or any amplifier you take, particularly these three elements. Of course, without even not only these particular elements, even you can go for some other networks or complex networks like transmission network, communication network, or anything it might be. Okay, as a matter of fact, you can use the dependent source concept for the sake of mathematical modeling of elements like what I said, electronic components or electrical components. Understand all of you? Okay, this is one important aspect why people are really using the dependent source concept. Another important concept is that you can also simulate negative resistance with the help of dependent source concept. I'm going to prove how to simulate the negative resistance using the dependent source concept. Okay, I'm going to prove it, okay, in the coming sessions, especially in the case of theorems. When we find the resistance for a dependent source networks, sometimes we may get negative resistance also. So how we get negative resistance and what is the significance of it, and what do we understand when we get the negative resistance, we are going to discuss that a little later. Understand all of you? Okay. So as of now, you take it for granted that the concept of dependent source is introduced for, okay, point number one, that mathematical modeling of elements like, okay, transistor, operational amplifier, or any amplifier. Okay, as a matter of fact, there are so many cases where we can really use this dependent source concept for the mathematical modeling, not only for these three elements, but also in some other cases, like especially communication networks and also even transmission systems and all, so on and so forth. Wherever you require mathematical models, okay, you can take the help of what? Dependent source concept. This is the first point. What is the second point? To simulate the negative resistance. Okay, for the simulation of negative resistance. So therefore, you can write down here what is the dependent source clearly. It is, please write down, it is an imaginary source. Or fictitious source. Imaginary source which does not exist. Which does not exist in reality. Okay, which does not exist in reality, whose value depends on either current or voltage, just like, look at this, either current or voltage elsewhere in the network, which does not depend, but here, which depends on either current or voltage elsewhere in the network. Hope you understand, all of you, okay? Now, you can also note down the concept of, this is the first point, second point, the concept of dependent source. Is introduced for number one, mathematical model. Mathematical modeling of elements like transistor, op-amp, or any amplifier. As a matter of fact, any amplifier, etc. You have so many things, but let us try to understand these three elements because we know very well. We have, models, standard models for op-amp as well as operational amplifier and transistor. We have certain models, yes or no? Okay, using hybrid parameter representation, you have some equivalent circuit models. Okay, then simulation of negative resistance. Simulation of, okay, negative resistance. Negative resistance. This is very, very important. Okay, so all of you please note down quickly all these points. I'll give you time. Okay, this is what about the independent source and dependent source concept. So what is a dependent source? It is an imaginary source which does not exist in reality. As I told you, if you go to any electrical shop or any electrical shop, let us say a battery shop or whatever it is, you ask him a dependent source, you can't get any response because that element does not exist in reality. Whatever the battery is giving, it is an independent source but not a dependent source. Okay. Note down that, all of you, quickly. As I told you in my previous sessions, you must document each and every point. That will help you a lot, okay? That will help you a lot in every exam. Document each and every point. Now you can see types of dependent sources. You have different varieties of dependent sources. Alpha into I, beta into V, A into I, B into V. Okay. The source is depending on current. The source is depending on voltage elsewhere in the network, somewhere. The current is somewhere in the network, and that current, the source is depending now. The voltage is somewhere in the network. Upon that voltage, this particular source is depending. So that is why I and V are called dependent variables. Dependent variables. I and V are called dependent variables. Okay. Now, what do you call it here? Since it is depending on current dependent, but it is basically voltage source. Current dependent voltage source. Voltage dependent voltage source. Current dependent current source. Voltage dependent current source. Okay. Since it is a voltage, the total units must be volts, but already amps is there. Therefore, what are the units for this? Ohms. And what are the units for this? No units. What are the units for this? No units. What about this? Already this is current, but already voltage is there. Therefore, this is Siemens or Mho. Okay. Note down that. Note down that quickly. Now, one more important point to be observed. This alpha, beta, A and B are constants. Yes or no? Now, the source value is equal to what? Constant into some variable. That means, it's something like that y is equal to mx. Yes or no? M is constant here. If x value is doubled, y is also doubled. If x value is halved, then y is also halved. So, in that sense, I mean to say, in the sense of what? In the dependent variable point of view, okay, in the dependent variable point of view, then the entire source value is directly proportional to what? The dependent variable. Yes or no? It's something like y is equal to mx. Y is equal to mx always refers to what? The linear relationship between y and x. Yes or no? Because m is constant. Similarly, dependent variable point of view, the source value is directly proportional to the dependent variable. In that particular sense, we can call all these sources as linear sources. Okay, we can call all these sources as linear sources. Therefore, write down that point. Note, dependent variable point of view. Dependent variable point of view. All dependent sources are called or can be called linear sources. Please write down, all of you, linear sources. Okay, this is a very, very important point. Now, this is all about the classification of energy source. The first classification is what? Ideal, practical. Second classification is what? Independent and dependent sources. Is it clear? Okay, well, now let's look at interconnection of energy sources. I think you have noted down this interconnection of energy sources. Interconnection of energy sources. Okay, that means when you connect energy sources in series or parallel, then we'll see, okay, how we are going to reduce the network. Okay, interconnection of energy sources. How can you connect them? You can connect them in series or parallel. Interconnection of energy sources. This is another important concept. Okay, classification of energy sources, interconnection of energy sources. Okay, so first let me take a simple example just to understand. You might be knowing already, but still I want to discuss. This will help us in analyzing the networks very, very easily. Okay, now look at this. For example, there is a source, energy source represented. What is this basically? You can call it independent source. You can call it ideal source. Yes or no? Okay, independent source or else ideal source. Now, if I ask you, what is the voltage at A? Then what could be your answer? What is the voltage at B? Then what could be your answer? Suppose if I ask the question, what is the voltage at A? What could be your answer? And what is the voltage at B? Then what could be your answer? Okay. Some people may tell that the voltage at A is 10 volts. The voltage at B is minus 10 volts. Some people, generally they are trying to give these answers whenever we are taking the classes in our regular classroom program. Most of the people try to give such kind of answers. I don't know how you are going to really define it, but I would say definitely the voltage at A, the voltage at B. The voltage at A, I do not know unless I know the value of voltage at B. I do not know what is the voltage at B unless I know the voltage at A. But I know one thing, that the voltage difference, the potential difference between AB is very much known to me. That is VAB, right? So VAB is a known value. What is that? VA minus VB. That means the voltmeter positive terminal is connected to A, the first letter. Okay. The voltmeter negative terminal is connected to B. Then how much it reads? Okay. Then how much it reads? That means you are asking VAB. Instead of asking, okay, in a lengthy manner, if I connect voltmeter positive terminal at A and negative terminal at B, what is the reading on voltmeter? Instead of asking such a big question, you can simply ask what is the VAB value. That's it, simple, right? So VA minus VB. Look at this. VA minus VB is equal to what? Actually here in this particular case, when you connect plus to plus and minus to minus, it reads as it is that value. Now you can observe that it is a single equation. It is a single equation, but how many unknowns are there? Two unknowns. Single equation, two unknowns. There is no unique solution. There is no unique solution. Hope you understand the point. There is no unique solution. That means what? There is no unique solution means what? There are multiple solutions. Yes or no? Therefore, what are the multiple solutions? If I assume this is 0, okay, then this is going to be what? 10 volts. If I assume this is 0, this is going to be what? 10 volts. If I assume this is 2 volts, that means I'm increasing. It will also increase 12 volts. If I assume this is minus 2 volts, that means I'm decreasing. This will also decrease. What is this value? 8 volts. You understand all of you? Okay. And there is a concept in the network that if you increase one particular node voltage by certain value, then the remaining all node voltage will also be increased by the same value. There is a concept. Decrease, then decrease by the same value. Okay. Therefore, If you assume this is 0, okay, then what do you get here? 0 means this is minus 10 volts. Again increase, okay, plus 2 volts, let us say, increase, that means minus 8 volts. Decrease, minus 2 volts, then minus 12 volts. I hope you understand the point now. So this is how you can interpret the given voltage source here. Now you can write infinite combination. That's why I told you there is no unique solution. That means multiple solution. There is no single answer for what is A, what is B. Yes or no, all of you, you can give multiple answers. But most of the times what will happen, the B is connected to the zero potential point, then A will be operating at whatever the value written over here. Okay. So please write down this first and then we can go for different cases once again. Please note down. You can also write VBA. What is VBA? That means you are connecting voltmeter positive to B and negative to A. Then how much it reads? VB minus VA. What is its value? How much the voltage the voltmeter reads? Definitely minus. Now, let us look at the series combination of voltage sources. You already know it. Please write along with me. Okay. I can say the voltage is VAB, potential difference, VAB. That means A positive, B negative you are taking, right? Therefore, you can take V1 plus V2. Another one. Write down all of you. V1, V2. Please write down A. Now, if I assume V1 is greater, then the polarities will become V1 polarities. If I assume V2 is greater, then the resulting polarities will be same as that of V2 polarities. If I assume V1 greater, I get plus minus, same polarities. If I assume V2 greater than V1, I get minus plus polarities. That's it. This is A, this is B. That means A is positive, B is negative. Then the voltage will be VAB. Then you get V1 minus V2. Here, B is positive and okay, B is positive and A is negative. I can call it VBA. Then it is V2 minus V1. How did you get all these formulas? Voltage. Again using KVL only. Yes or no? Okay, Kirchhoff's voltage law only you are finding. VAB is nothing but you are starting from A and reaching B, touching positive first, therefore plus V1 plus V2. Here also VAB. VAB means A positive, B negative. Where do you start? You start at A and reach B. Okay? In touching concept. But touching concept is nothing but KVL only. We put another name for it. But we are just directly or indirectly applying Kirchhoff's voltage law only. So A to B when you go, you're touching plus first, then you're touching negative first. Therefore V1 minus V2. Similarly VBA, you start from B and reaching A, you're touching plus first, then minus first, V2 minus. Please note down. Coming to now, current sources. Parallel combination of currents. Okay. You cannot open it. As you know, current source must not be open. Assume that there is a load, okay? Otherwise it is a meaningless. Just now we have seen in the last previous sessions that the current source must not be open. What is this? I1 plus I2. Similarly, I1 is up, I2 is down, let us say. I1 is greater than I2, assuming that, then the resulting current direction is same as I1 only. That means I1 minus I2. I2 is greater, then the resulting direction will be I2 minus I1. Please note down. So these things already have studied well. I know that. So please quickly complete them. We need to speed up at certain places, particularly where we know very well. Some examples. Example 1. Please note on this and what is the current value I. Another example. Okay, let's try to find in both the cases what is the current I and what is the current I. See, there are many ways to solve the network, but let us try to apply this interconnection of sources because we are learned just now, right? So let us try to apply. And when the problem is given in the exam, how to do it, that we'll discuss later. This is only to experience, to simplify the sources and replace by a single source. Now, voltage sources can be replaced by a single source. Resistors can be simplified and can be replaced by a single resistive element. Current sources can also be simplified, okay, and replaced by a single current source, okay. And voltage sources, when series connected, you can replace by a single source. Current sources, when they're connected in parallel, you can replace by a single current source, right? That we can try to apply here, okay. So now let us see. the first example. Okay, how all these sources are connected here? They are in series, right? And now let's try to find the current through this particular resistor. But tell me, can we interchange these? Definitely, right? Okay. Can we interchange? Can we represent all the sources side by side to this particular source and then take the resistors like this? Yes, we can do that. Now something like this. I told you there are so many ways. Now my intention here is what? Only to experience the interconnection of energy sources, series combination of voltage sources, parallel combination of current sources, nothing else. Okay, otherwise we can easily solve it. Now something like that. What is this? 2 ohm, 3 ohm, okay, 4 ohm and 1 ohm. What about this? Plus minus, minus 10 volts, and here minus plus 25 volts, and this is already 20 volts, and this is plus minus minus 5 volts. Okay, now look at this. With respect to these two terminals, if you see all these sources are connected in series, can we replace these sources by a single source? Yes or no? Yes, we can, right? Therefore, now look at this. Assume that any one of these sources is dominating over the other. Just like now what we have seen in the previous case. Now we have seen the previous case, right? What is the case that we have seen? V1 greater than V2 means V1 minus V2. V2 greater than V1 means V2 minus V1. Okay? Then you take now some particular source is dominating over other. For example, 20 is dominating, let us assume, for example. Then what will happen? The resulting terminals will also become what? The same as the 20 volt source only, right? Now, if I take like that, now I get something like this. Okay? 20 volts. 20. Now, you just move in this direction. You will understand that. Now, minus to plus and plus to minus. That means they are having opposite polarities. Okay? Therefore, what do you get? Negative of minus 5. Then again, you are coming like this. Then minus to plus. That means same as. That means same. Plus of, but minus 10. Now coming here, plus to minus. Plus to minus means what? Opposite polarities. That means minus 25. So what are you getting here? 20 minus of minus. What is this? Plus 25. Then minus 10. Then what do you get here? Minus 25. You got cancel. Then finally you got minus 10 volts. So this particular source value is how much? Minus 10 volts. Then what is the resistor value here? This is 10 ohm, because 3 plus 2 plus 4 plus 1, 3 plus 2, 5, 4 plus 1, 5, 5 plus 5, it is 10 ohm. Then what is the current actually you are going to get here? You are going to get the current I is equal to minus 10 by 10. This is only to experience that how we are simplifying these sources. That's it, nothing else. Or else, some people try in this way. I call VAB, okay, A and B here. I just want to find VAB, treating A as positive and B as negative. Now VAB, or VAB means what? From A you have to start with plus and reach the B, that is minus. Okay, use the touching concept. When you use the touching concept, what do you get? Tell me. Now minus of minus 5 plus 20 minus 25 plus, okay, of minus 10, like that. Again, what are you getting here? 20 minus of minus plus 25, 25, 25 gets cancelled. Finally, what you left with? Minus 10 volts. This is also a way to solve the network. There are so many ways to solve the network. Anyway, we are going to discuss that. Using even mesh analysis, directly you can find the current. But my intention here is what? Only to understand how we are reducing, okay, the network, making use of the series combination of all voltage sources can be replaced by a single equivalent voltage source. That is my concept here, okay? So please note on that. Okay, from this we're going like this. Okay, let's go with this particular problem now. See, there are four sources, and we should also understand how they are connected. How all these three are connected. I mean, all these elements are connected here. Parallel. This element also connected between this point and this point. But this point and this point all are same. Yes or no? Therefore, I can redraw the network something like this. The 50 amperes can be also connected here in downward direction parallel to this element. Yes or no? That means all elements are connected in parallel. So let us replace that entire network by a parallel combination. Okay, something like this. Now, it's something like this. This point and this point are operating at same potential. So even if you cut this and connect here, it does not make any difference. For example, if there is any resistor here, it is not possible to connect this particular wire here. Yes or no? But there is no element at all. All these points are operating at same potentials. So therefore, I can take it as an advantage to connect this point here. Okay, so that's what I've done here between these 2 points. Now 50 amperes. Okay, what about this particular element? 18 ohm. What is this? Minus 10 amperes. Okay, so please 30 amperes. This is minus 10 amperes. Okay, yeah, minus 10 amperes. Minus 10 amperes. What about this 4 ohm? Okay, what about this minus 30 amperes? 9 ohm and 20 amperes. Now, when all current sources are connected in parallel, you can replace all current sources by a single equivalent current source or not. Okay, so assume that 20 is dominating here. Okay, 20 is greater. Let us assume there is nothing wrong. And the question is, what is I here? Okay, so 20 is greater than 20, but this is downward, this is up, this is down. When you have down, then minus of minus 30. This is up. When this is up, plus off, but the value itself is minus. This is down, then minus 50 here. Okay. This is what the resulting current value, that current source value. What is this I actually here you're going to get? Tell me. Now 20 minus of minus plus. That is 30, that is 50. Then 50 got cancelled, and finally you are left with what? Minus 10 amperes. That means you got something like this. This is minus 10 amperes. This is 9 ohm. This is 18 ohm. Okay, this is what? 4 ohm. And you are expected to determine what is the current flowing to this. How these two elements are connected? Parallel. 9 parallel 18. 9 into 18 by 9 plus 18. You get 6 ohm. Now finally you got here something like this. Now 6 ohm. And what? This is 4 ohm. So what is the current actually here? Minus 10 amperes. Then you are expected to determine what is I here, right? So I is equal to, okay, opposite resistance 6 by 6 plus 4 into minus 10. So 10 get cancelled, and finally you got minus 6 amperes. Okay, I told you clearly that my intention is to just to understand how we are going to replace the parallel combination of current sources by a single equivalent current source. Otherwise, the same problems can be, this problem can be solved by mesh analysis, that problem can be solved by node analysis. Okay, but we are not going to that stage. We have anyway a lot of things to discuss with respect to mesh analysis and node analysis. That we will see later. Note down quickly. Note down, all of you. First you note down this. We have seen the series combination of voltage sources, then let's see the parallel combination of voltage sources. Later we'll go for series combination of current sources. Okay, so look at this. If two ideal voltage sources are connected across each other, that is V1 and V2, with respect to AB terminals, then I want to replace it by a single equivalent voltage source. Then what is it